We have a VIVAX TV in for repair today. Here's the model number. It is a TV-32LE130T2, and oddly enough it says made in Croatia. I highly doubt that, but sure. This TV is in for repair today because when I try to turn it on, there is no picture. Now, at first I assumed that this will just be another case of bad backlight, but upon looking a bit closer, like the TV is currently on, and typically when you have a bad backlight, you can just grab a strong light such as this one and put it on the screen, and you would typically see something on the screen. And on this TV, if I try to do anything, it doesn't do that. And if I try to turn it off, it is now off. And when I turn it on, it does whatever the heck this is. It almost looks like the TCON or the display itself is bad. But a failed TCON or a failed display wouldn't cause no backlight, which makes this repair kind of interesting. So let's take the TV apart and see what we can see from the inside. Okay, so the TV is apart, and at first glance I don't see anything wrong. First discharge the... oh, that was a spark. The primary capacitor. The rest of the capacitors look fine at first glance. So first thing I want to try is I want to grab the multimeter, set it on voltage range 1000 volts. I'm going to plug the TV in. This right here is our cable for the backlight. First I want to see whether or not there is any voltage going to the backlight. 22 volts, that's not a lot. 60, 50, and then dropping. That's interesting. So we do have voltage going to the backlight, but the backlight isn't coming on, which would explain why there is no backlight, but it doesn't explain why we're only getting garbage on the display. So what I'm going to do next is I'm going to take the entire TV apart, and I'm going to get to the LED backlights and check whether or not any of the LEDs is actually faulty. Well, there has been a development. So here's the display that I've taken off. So these lenses, these diffusion sheets and whatever the heck these are glued to the display, so I'm not going to try to disconnect them. However, the development that I saw is, this is really fragile because this is a display, is I noticed this. This chip looks like it is very much exploded. And the other one looks fine. This is how it's supposed to look like. And this is how it looks. Okay, so it's obvious that I'm not going to be saving this TV, but I'm still curious because these are two unrelated faults, the backlight and the display. If one fails, it's not going to cause a failure of the other. I still want to test whether or not the LEDs themselves are okay. Okay, so this is what I noticed. This LED not only looks like it has exploded, but there are also marks of corrosion around this LED. This LED right here also looks like it's exploded. This one also, so this might imply that this TV has been used, oh, this one especially, this TV has been used outside. What I'm going to do is I'm going to jump all the LEDs here that are faulty, because these are all in series. As you can see, the red one, the black cable goes to this one, and the red wire goes to this one, and there is a white wire connecting these two together, which means that these are all in series. So I'm going to jump all of these that are bad, and I would like to try to cut out the broken driver on the display panel itself. Of course, the TV itself will be pretty useless. This TV is junk, it's cheap garbage, and the display is obviously dead. But I'm curious if we can get half of this display working. So I'm just going to keep playing with it. Well, I don't know what to say. Literally 2 out of 12 LEDs are working, and that's this one and this one. All the rest of them are either dead or shorted. What the heck happened to this TV? Maybe a short circuit in the driver caused way too much voltage to flow through the LEDs, killing them all. You typically have one or two or three LEDs that are bad, but these are literally all dead. I don't know how this would happen. So change of plan. I'm not going to jump every LED because that would be stupid. What I'm going to do is I'm going to put the display back together, and I'm going to use my recording light to light it up and see if we get half of the display. If I disable the half of the display with a burnt driver. Okay, so we are back, and yeah, it just cuts out. The display is now just white. So what I want to do is so this is the faulty side, the side that actually shows lines, and that's probably the side where the driver is burnt. So now I want to try to cut the cable going to the driver and see if we get the picture on this side of display. I mean, the TV is still useless, but it's just an interesting experiment. So this was the side that showed the garbage. If I unplug it, why is it still glowing? And yeah, that is the burnt chip right here. There is a ribbon cable right here, and there is a ribbon cable right here. And this is the burnt one. So now I'm literally just going to take a knife and cut the ribbon cable off. and now I want to see if we get normal picture on the other side. I already made the video about this when I was repairing that Dell ultrawide monitor with a crack on the screen, and there I explained why this worked. Okay, if I now plug it back in and take the recording light, put it on the display and turn it on, we should see at least something. Okay, well, it is something. There is nothing on this side because this side is disabled, and on this side we're getting lines. Well, okay then, and it is safe to say that this TV is just dead. It was an interesting experiment though. If you have any guesses on what happened to this TV, you're welcome to tell me in the comments, but I'm assuming it was either used in very wet, in very humid environment, or there was lightning involved. Somehow the motherboard and the power supply, the things that typically fail the first when in case of a lightning strike, they appear to be working fine. How? Okay, so that's it for this video. I hope you found this somewhat interesting. I did. See you in the next video. Nice.